This is the second episode in the how-to series for SDI's evolutionary algorithm, E. This time we're covering how to test the programs we evolve with E. We'll run the area circle example. In cleandata.dat, we have 6 examples of the problem, each accurate to 2 decimal places. To begin testing, we'll press the test button. E produced 5 independent solutions numbered 0 through 4. Int tells us this is a program. Cleandata tells us which file this program was evolved to solve. And Pi tells us this is a Python program. E can also write C++ and Fortran programs. Let's pick the first one. Now let's choose our original data set, cleandata.dat. As we can see from the low error and good predictions, this program does a marvelous job of predicting data in the set from which it was evolved. All the predictions are accurate to at least 2 decimal points. That was the accuracy of the training data set itself. What happens when we predict against another training data set? Noisydata.dat is a data set derived entirely by manually measuring the area on graph paper. We do not know what its accuracy is. Let's run it. This is troubling. Our great program is now much less accurate. Error has grown from 0.002 to 0.22. We know the program is good, so what's the problem? Unfortunately, data measured in the real world is not perfect. Cleandata is not particularly good at predicting noisy data. Let's try this again, evolving a solution from the noisy data. We press Pick Problem and choose the noisy data. Now let's run E again. We used really good data to create a program, but that program did not predict the noisy data very well. Error was 0.22. Evolving solutions to the noisy data did not eliminate prediction error, but it did reduce our error. Let's choose Test again and get more details. We'll choose the Python program that we evolved from the noisy data, and we'll test it on the noisy data. A quick glance at the data confirms that we're now doing a better job of predicting the noisy data. Using the noisy data, E reduced its estimate of pi to 3.13. Not only was our data noisy, it had a systematic bias towards slightly smaller area. Unfortunately, that's the nature of noisy data. We hope the errors cancel each other out, but that's not always the case. The best prediction happens when we collect data that is characteristic of what we want to predict. After running, E leaves Python programs in the problem folder. For example, int cleandata.py is the Python program evolved to solve the clean data problem. After testing, E leaves result files in the problem folder. These files record how well a program performs against a particular data set. For example, int cleandata0 predicts clean data tells us how well the program evolved from good data predicts the good data. We've seen that E can predict clean data with great accuracy. We've seen that programs evolved from clean data do not predict noisy data particularly well. Also, we've seen that E will pick up on any systematic bias in the noisy data to improve its prediction. E makes testing your solutions easy and helps you understand the usefulness of the solutions you evolve.